Okay, welcome to part 2 of this assembly. Now that we've got the ball, the sleeve, the washer and the nut in place, the last thing to do is to place the bracket and the bolt in position. Just have a look back in the PowerPoint and see what that looks like. So we'll skip back to the workshop drawing. And we can see here that we've got a side view of the tow bar and the bracket in position. And it appears to me that it's mid-placed between this bend in the tow bar and this bend in the tow bar, and we would assume that it would be placed even with an even amount of overhang or underhang either side of the tow bar here. So this 52 millimeters wide, and we can see here that the tow bar is 75, so there's going to be a 11, I think it's 11.5 mm overhang both sides, or underhang I should say. So with that in mind, we can go to our assembly and we can follow that same procedure that we normally do by bringing in the bracket. So we'll go find the bracket, there it is there, and open that. And it's always good practice to get your object roughly in the right sort of orientation before you start putting constraints on. So that's roughly in the right spot, so what I'll do now is select that surface and the underside, flat side of the bracket there. It's defaulted to an angle, we don't want to do that, we want a coincident constraint, and we might then just use the coloured axial constraints here to bring it closer into the position that we want it to be in. You can see here we can still move these around roughly into the right spot. So rather than just doing it roughly, let's make this precise. So to make it precise, we really do need to know the distance between this edge of the curve and this edge, and make it halfway between those 2 points. And then we'll make the faces out here, this tow bar face and these faces, the same distance away on both sides. So we'll do that constraint first. So what we'll do, I'll show you how to use the analysis tool, which allows us to measure distances. So if you've forgotten, you can work it out. So up in the analysis tab up here in the ribbon bar, click on analysis, come across to the measure tool, and while we're in the measure tool we can see all the different ways of measuring volumes, surface areas, you name it. The third one across is distance, so I'm just going to click on the distance to activate it. And if I wanted to know the distance, say from that edge there, hold down control, select the other edge, and it tells me that's exactly 75. And then I could also do the same for the face and or the edge of the bracket. So I'll choose that edge there, hold down control once again to that edge there, that's 52. So we say to ourselves, we want this to be evenly placed between, so if we take 75 minus 52, what's that, 23, and then we want an equal amount either side, so 23 divided by 2 gives me 11.5. So if I remember, I need 11.5 from that face to this face, we should be able to then constrain it to that. So get out of the measuring tool by closing that box down, go back to the blue component placement box here. Then we can choose this outside surface here by clicking on the object once and then clicking onto the surface, and then we might zoom in a bit and see if I can get that outside surface of the, that's not being very nice to me, of the bracket. I might just check out what's going on there. The stupid thing jumped out of mode again, so what I'll do, whoa, okay, it's doing something really crazy now. Let's cancel that, cancel that. A few issues with my mouse at the moment. Okay, we're back to the bracket, don't know what happened there. That was a bit bizarre. Okay, so back to constraining these two faces here. So select this one, select that one, and always just, if you can, make it go in the direction you want it to go. So change it from coincident to distance, and we should be able to drag it along that axis. It's not being very nice, just keeps on defaulting to weird things. Try distance again. Okay, that's not being very nice to us for some reason. Oh, it's lost its placement. Okay, so I'm going to just check what's going on here. There was a coincident constraint there. Then there was a distance constraint. And for some reason it put another one on. So I'm going to then delete this last one by selecting it, clicking delete. Then I'm going to go back to this one. And you can see here distance, there's two surfaces. And then I should be able to pull that aside, which I can. And then I'm going to change the distance from whatever it was to 11.5. That was a bit of a drama to do that, but eventually we can now see that is mid-placed. So that's good. So we like that one. So to go to the next constraint then, we'll click on New Constraint. And now we need to make the distance between these two lines here, bends there and the bend there. We're going to make this equal distance here as well. So while we're still in that process of assembly, we can go Analysis, Measure, Distance. And I'm going to select that edge there, hold down Control, and also select that edge there. And it tells me that's roughly 58 millimeters. So if that was 58 millimeters, and I know that the width of this bracket was 25, 58 minus 25, what's that, 33. So if we said 33 millimeters left over, divide that by 2, what's that, 16 and a half. So 16 and a half millimeters then from that edge to that face there. So jump out of the measuring tool, close it down, and go back to our component placement mode, and go back to placement, make sure we see what's going on. Yes, so it's looking for some information, so what we'll do is we'll select that edge if we can. Now we'll just select the component first, might roll that over. That face there, you can see it's stored to, I'm going to right click until I get that edge, which I did, hold down Control, actually I shouldn't hit Control, just right click until I get the edge pre-hided, then left click, and you can see it's now stored it. Change it from coincident to distance, and then we need to offset that at a distance of, I think we said 16.5. So I'll just drag it that way so it kind of knows, and then 16.5 and enter. Let's have a look. It says fully constrained, looks like it's in the middle. Good, we'll accept that. Oh goodness, jumped into rendering for some reason. Looks like it's still in the right spot though, which it is good. And then the last thing to do is to bring in the bolt. So we'll do that by clicking on Assemble, go find the bolt, there it is there, click Open. And what we've got to realize here is because we drew this bolt with a swept blend function, the only part that we can use to really successfully assemble this is this cylindrical section on the end here. So I know that this is a threaded end on here, there's a cosmetic thread on there, and looking at my bracket I can see this is a wider hole than this one, which means that this end must have the cosmetic thread on it. And if I actually hover there, you can see the blue line representing the thread. So this end is going to go to that end there. So what I might do first of all is I might see if I can spin this around to get it kind of in the right spot to start with. Right sort of orientation, that looks better. And then what I might do is I'll grab the surface on the end of the bracket, that one there, and then the surface on the end of the block, not the pin, sorry, the end of the bolt. Can't get that select for some reason, it's being a pain. I'll check my placements. Yeah, it should be accepting it. Try that again. There we go, eventually. Selected that one, and I want to make them coincident, which means you can see it's lined up there. And then we grab the outside cylindrical surface, or new constraint first. outside cylindrical surface there, inside cylinder there, and that's coincident as well. And it's fully constrained. Okay. Alright, so dealing with parts that are being created with different methods can sometimes be quite difficult, and if you understand that placement tab within the constraints or within assembly, it's going to make life a lot easier for you. So good luck with that, and I suppose we can then from there start create our assembly drawings.